Take a China rose flower. Pull out a petal from the flower and rub it on a piece of paper. Split the paper into 2 parts and place one of the halves on a piece of sliced lemon and the other half of the paper on a bar of soap. What do you observe? Even though we have placed the same paper on the lemon and the soap, both of them exhibited different colors. Can you guess the reason behind this phenomenon? Acids and bases. The main characteristics of acidic substances is that it tastes sour. Examples of acidic substances are curds, which contain lactic acid; lemon juice, which contains citric acid; tamarind, which contain tartaric acid; and vinegar, which contains acetic acid. The characteristics of basic substances are: it tastes bitter, it is slippery to touch. Examples of basic substances are baking soda and milk of magnesia. Commonly used natural indicators are litmus paper. There are 2 types of litmus papers: red litmus paper and blue litmus paper. Take 1 red litmus paper and dip it in the beaker containing acid. Let us see what happens. There is no change in the color of the litmus paper. Now, let us dip the red litmus paper in a base, and let us observe what happens next. We can see that the base changes the red litmus paper to blue. Now, take a blue litmus paper and dip it in the beaker containing acid. You can see that the acid changes blue litmus paper to red. Now, let's see what happens when you dip the blue litmus paper in a base. You can see that there is no change in the color of the litmus paper. Another commonly used natural indicator is the China rose petals. Prepare a China rose solution by putting its petals into warm water. Take a few drops of China rose solution and pour it into a beaker containing acid. You can see that the acid changes to light pink in color. Repeat the same process for the base solution. The color of the base solution changes to green. Another natural indicator is turmeric. Now, let us make some turmeric paste and spread it in a paper and dry it. Now dip the papers in an acid and a base simultaneously. You can see that the papers turns yellow in acid and reddish brown in base. Commonly used synthetic indicators are methyl orange. Now put some drops of methyl orange in 2 beakers containing acid and base. You can see that acid turns red in color and base turns yellow. Another synthetic indicator is the phenolphthalein. Take some phenolphthalein and repeat the same process which was shown earlier. You can see that the phenolphthalein changes color, acid remains colorless, and base turns pink. Now, you have understood how indicators are used to identify acids and bases. Having discussed about acids and bases, let us see how acids and bases take part in various reactions. Reaction of acids and bases with metals. Take some drops of dilute hydrochloric acid in a test tube. Then, add some zinc granules into it. You can observe some sort of salt is forming in the test tube and a certain gas is coming from the zig granules. Now let us divert the gas to a soap solution and see what happens. You can observe that some bubble formation takes place in the soap solution. Now, take a burning candle and bring it near the gas. You can observe the gas burns with a pop sound. Now let us repeat the same process, using sulfuric acid and nitric acid and see what happens. What conclusion can be drawn from the above experiment? When acid react with metal, salt and hydrogen gas are produced. Reaction of metal carbonates with acids. Take some drops of dilute hydrochloric acid in a test tube. Then add some sodium carbonate into it. Now place a test tube containing calcium hydroxide solution at the other end of the delivery tube, so that the gas formed in the first test tube will be passed on to the calcium hydroxide solution. What changes do you observe? Here, calcium hydroxide solution turns milky. This indicates the presence of carbon dioxide gas. Reaction of acids and bases with each other. Let us fill one burette with sodium hydroxide. Place a conical flask underneath the burette. Open the nostril of the burette and pour 50 milliliters of sodium hydroxide into the conical flask. Add some drops of phenolphthalein indicator and see the change in the color. Now let us take in another burette and fill it with hydrochloric acid. Place the conical flask underneath the burette containing hydrochloric acid. Pour hydrochloric acid from the burette into the conical flask. We can see that the pink color starts diminishing and after a while the solution becomes colorless. What might be the reason? The effect of the base is nullified by the acid. Let us again place the conical flask underneath the burette containing sodium hydroxide. You can see that the pink color appears again, which gives us the conclusion that the solution is now basic. Let us look into the chemical equation of the above experiment. Sodium hydroxide plus hydrochloric acid gives you sodium chloride plus water. The reaction between an acid and a base to give a salt and water is known as a neutralization reaction. In general, a neutralization reaction can be written as base plus acid gives you salt plus water. Reaction of metallic oxides with acids. Take a small amount of copper oxide in a test tube, and add some dilute hydrochloric acid, and stir it slowly. We see that the solution becomes blue-green in color. It is due to the formation of copper chloride in the reaction. In general, metal oxides reacts with acids, forming salt and water. How strong are acid or base solutions? The behavior of acids and bases in a reaction depends on its strength. How can we measure the strength of acids and bases? We measure the strength of acidity and basicity using a scale which measures hydrogen ion concentration in a solution and is known as pH scale. The pH of a neutral solution is 7. Values less than 7 on pH scale represent an acidic solution. The strength of the acidic solution depends on the number of hydrogen ions. Values greater than 7 on the pH scale represent a basic solution. The strength of the basic solution depends on the number of hydride ions.